Welcome to the Resairchia YouTube channel. My name is Jorge, and in this video I will introduce you to the use of Julia functions in our Modia models. I will start by loading the Modia and plot packages. Meanwhile, I have this little model written in Modelica. It is an example showing a perfect bouncing ball. We start at an initial height and with an initial velocity. We have our gravity represented by the parameter g, and E represents the restitution coefficient, meaning that we will lose energy or not when bouncing. In our case it's 1, so we will have a perfect bouncing ball. These two equations represent the motion of our ball. This when statement represents our contact with the ground. I will leave a link in the description of a video tutorial explaining the use of the when statement. When we simulate this example, the result is something like this. We will keep bouncing back when we hit the ground. And we can see the change in our velocity at the moment we hit the ground. We have a perfect percussion here, changing our velocity in sign, so we will start moving upwards. Now I will try to model the same behavior using Modia. I will copy paste the code to go faster. So in the same way, we have an acceleration representing gravity. We start with an initial velocity and at an initial height. Then we need to instantiate the model and simulate. We will plot the results to see what happens. As you can see, we don't have anything that models the contact with the ground, so our ball keeps falling. For the moment, I don't know if there is any kind of when statement in Modia, since it is still under development. So, since we want to find out how to use and if it is possible to use Julia functions with Modia, I will model the contact using a function. The function f in this case needs two inputs, the height and the velocity. If our height is bigger than 0, we return 1. Otherwise, we return minus 1000. I am not using the velocity here, but my goal was to show how to add different inputs to a function. Then, in our bouncing model, we have the same equations, but when we hit the ground, we have the result of our function, which in this case is a very big acceleration with opposing sign. This is similar to the way of modeling a percussion. This is not completely correct, but since our goal is to use pure Julia functions together with Modia, it is good enough. Now I will instantiate and simulate the model. I have added a few arguments to the plot function to get a better plot. As you can see, we have the same result as the Modelica model. Thank you so much for watching, and see you in future videos.